All right, the next thing that we're going to look at in related to differential equations is something called a slope field. All right, and there's generally always like one of these questions on the AP exam just because they have these pictures that are kind of interesting. All right, so a slope field is a visual representation of the possible solutions to a differential equation of the form y prime equals f of xy. All right, this basically means the right-hand side has x's and y's mixed together, but it's just equal to a single y prime. All right, remember y prime is the derivative of my function. It tells me the slope of the tangent line. So basically this is going to be a bunch of slopes depending on what x and y value I plug in. So my slope field is basically going to be a small indication of the slope of the answer at each point. Sounds kind of confusing, but here's what they look like this. So this is y prime equals 3x plus 2y minus 4. All right, so that's my differential equation. And this thing below it is the slope field for that. So for instance, let's say I wanted to find what happens at the point 1, 2. At the point 1, 2, my y prime is going to be equal to, when I plug in 1 for x and 2 for y, I get 3. So at the point 1, 2, which is this point, my slope should be 3, and it is not. That's what I just realized looking at this graph that it's a little confusing because they didn't put numbers on it, and I forgot to double check, but these go by half increments. So this is 1, 2 would be 1, 2 would be that point, and you can see the slope is going up. Just like we know if it's a positive slope, it should be 3. All right, so another one might be if I plug in, let's say 0, 4. All right, 0, 4, y prime should be 4. So we go up to 4. 1, 2, 3, 4. That's here. And you can see again the slope is a little bit steeper than the slope at 1, 2, which was 3. So basic idea is this gives me, if there's any specific point, I can plug that in, and that gives me the slope of the tangent line at that point. And basically in this picture, they've done it for every value from, looks like -5 to 5 for x and for y. All right, so I have all these slope fields, and now I know if I want to start at a specific point like 1, 2, I have a basic idea of what the answer is going to look like. All right, so kind of like what I just said, I can use the slope field in order to predict the solution to a differential equation with specific initial conditions. All right, so we know if we have the slope field, we can kind of use the directions of the arrows to predict the answer. All right, so consider the following slope field. Sketch the graph of the solution that goes to the point -1, 4. All right. Well, -1, 4. Oh, it should be -1, 2, because again, there's half increments instead of 1 increment. So -1, 2 would be there. And then we kind of just follow the slope. So the slope's there, going to lead me that way, and then probably level off there, and come back around and go up. So I'm kind of just following the pattern of the slope fields and kind of just following the arrows until I get to another arrow and using that new slope and kind of just using the kind of general direction of the arrows to get a solution. So that would be the most likely picture if I was looking for the answer that goes to the point -1, 2. What about the point, say, -2, 1? All right, -2, 1 would be here. I would go straight down more, and you can see it levels off at this perfectly straight line. As soon as I'm there, I'm going perfectly straight, and it just levels off forever. All right, and going backwards, it goes backwards up the arrows, something like that. All right, so again, I get these general pictures of the solutions for my differential equation by using the slope field. You also might notice that there's these things called equilibriums, which is a place where if you start at one y value, you stay at that y value. So if I started at 0, you can see I'm just always going to keep going to the right forever. That's an equilibrium. If I just plug in 0, it'll stay 0 forever. All right, so you might see on the web assigned problems something asking for equilibrium. Those are basically just asking for any of these flat places where it just levels off. If you start on that level, you stay on that level forever. All right, so that's the basic idea of slope fields. All right, they're just a picture that represents the slopes of your equation, and you can use them to help sketch graphs. All right, so if you know those two things, you understand slope fields enough for this class.